Alright guys, so in this section 4.3 we are page 269 and we are going to try to do a set of problems. You have watched obviously the lecture note and you have prepared your lecture note. I will go back and do another video to re-insist on some of the points that I think are key points that I think are very important. But right now let's try to do these problems. And in this problem number 1, find a cubic polynomial in standard form with real coefficient having the given 0. So basically in problem number 1 they are telling you that x equals 4 is a 0 and x equals 2 plus I is a 0. By using the theorem that is defined as the conjugate 0 theorem, if you have a 0 a complex, the conjugate of this 0 will be also a 0 of your polynomial. So x equals 2 plus I is a 0. So therefore, x equals 2 minus I is also a 0. So I would like to remind you that they are giving you x equals 4 and x equals 2 plus I. And by using the conjugate 0 theorem, so actually I'm not going to present this way. Conjugate 0 theorem, we end up to have x equals 2 minus I, also another 0. So right now we have 3 zeros, and I would like to remind you that they are asking you to find a polynomial degree 3. So if they are asking you to find a polynomial degree 3, that means that you know that your polynomial is defined as a ax cubed plus bx squared plus cx plus d. And so that means it would be a 3 parentheses. And that is pretty easy because now you can say that x equals 4, that means the first parenthesis will be x minus 4 equals 0. X equals 2 plus I, that means x minus 2 minus I will be the second parenthesis. Why minus 2 minus I? Because x minus 2 plus I will be equal to 0, and I just distribute the negative 1 to 2 and the negative 1 to plus I, which gave me x minus 2 minus I. And I have also, finally, x equals 2 minus I, giving me x minus 2 plus I equals 0. So I have my 3 parentheses. Therefore, I can write my polynomial p of x equal x minus 4 times x minus 2 minus I times x minus 2 plus I. And what I want to do is just distribute, first of all, 2 parentheses together, and finally another one. So I'm going to look for x minus 2 minus I times x minus 2 plus I, and I'm going to distribute the x with the x with the negative 2, the x with the I, and do the same with the 2 and with the I. Okay? All right, so just going to get rid of this, and I end up to have x squared minus 2x plus ix minus 2x plus 4 minus 2x plus 4 minus 2x plus 4, because negative 2 times negative 2 give you plus 4, and minus 2i. And the last one is going to be negative ix minus ix. Then negative I times negative 2 give you plus 2i. And the last one, negative I times I, give you negative I squared. End up to have x squared. Now this one I can get rid of. Then negative 2x, negative 2x, negative 4x, negative 4x. Negative 2x, negative 2x. Then ix minus ix, that cancel out. Negative 2i plus 2i cancel out. Minus I squared, it's the equivalent of negative 1, which is plus 1. 4 plus 1 equals 5. Equal 5. Now, what I want to do, I'd like to remind you that p of x, basically, p of x equal now x minus 4 times x squared minus 4x plus 5, and I'm going to distribute. So that gives me p of x equal x cubed minus 4x squared plus 5x minus 4x squared plus 16x minus 20. End up to have x cubed minus 8x squared plus 21x minus 20. And that is our polynomial p of x. Let's try to do another one. We have problem number 3. We have x equal 3. It's x equal 5 and x equal I. That directly gave me, using the conjugate theorem, that x equal negative I is also 0. So therefore x minus 5 equals 0 is the first parenthesis, x minus I second parenthesis, and x plus I third parenthesis. So my polynomial, which is a polynomial degree 3, it's a cubic polynomial. So polynomial degree 3 will be x minus 5 times x minus I times x plus I. So I'm going to focus first of all to x minus I times x plus I. And there is two options for me. I can notice that this reminds me a minus b times a plus b, which is supposed to be a squared minus b squared. In that case, this is going to be x squared minus I squared, which is x squared minus negative 1, and that you have x squared plus 1. If you don't remember that a minus b times a plus b equal a squared minus b squared, or if you don't see that what you have looks like a minus b times a plus b, just distribute properly and you will find what you're looking for. So now I can clearly write that p of x equal x minus 5 times x squared plus 1, and so p of x will be equal to x cubed plus x minus 5x squared minus 5. And so p of x equal x cubed minus 5x squared plus x minus 5. All right, now let's try to do another problem. And what I want to do is the problem number 9. So in this problem number 9, what do we have? In this problem number 9, we have find the polynomial p of x degree 3. So we know that the question is find the polynomial p of x degree 3. So ax cubed plus bx squared plus cx plus d with 3 real coefficients. And they are giving you the zeros. They are telling you x equal negative 2 is a 0. X equal 1 is a 0, and x equals 0 is a 0. Therefore, you end up to have x plus 2 as a parenthesis. And so therefore, I can write my polynomial p of x equal x plus 2 times x minus 1 times x. But they are giving you in the direction of your problem that p of negative 1 equal negative 1. P of negative 1 equal negative 1. That is an indication for you that you must have a coefficient a in the front, and p of negative 1 equal negative 1 will help you to find the value of this coefficient. So what do? That's pretty easy. We are going to substitute p of negative 1 by negative 1 inside my polynomial, and it will be equal to a times negative 1 plus 2 times negative 1 minus 1 times negative 1. That gives me a times 1 times negative 2 times negative 1. I end up to have negative 1 equal negative 2 times negative 1 give me plus 2. 1 times 2 equal 2a. So I end up to have a equal negative 1 over 2. Therefore, I end up to have a polynomial p of x equal negative 1 over 2 times x plus 2 times x minus 1 times x. So the only thing I need to do is to distribute to find the expression of my polynomial. So if I do negative 1 over 2 times x plus 2 and I distribute the x to x minus 1, that gives me x squared minus x. And then I'm going to distribute this one and I do not change negative 1 over 2. X by x squared give you x cubed. X by negative x give you negative x squared. 2 by x squared give you plus 2x squared. And 2 by negative x give you negative 2x. I end up to have a negative 1 over 2x cubed because I distribute my x cubed. Negative x squared plus 2x squared give you x squared, so minus 1 over 2x squared. And negative 2x multiplied by negative 1 over 2 give you plus 1x. So the answer is supposed to be negative 1 over 2 x cubed minus 1 over 2 x squared plus x. Let me try to do another one for you to make sure that you do understand what I'm doing. So we have problem number 12. In the problem number 12, we have x equal negative 7 and x equal 2 minus I. Right away, you know using the zero conjugate theorem that x equal 2 plus I will be also a 0. So your polynomial will be written as p of x equal x plus 7 times x minus 2 plus I times x minus 2 minus I. But there is a coefficient a in the front because they are telling you that p of 1 equal 9. And that just shows the fact that we have p of x equal a coefficient a times 3 parentheses. So how to find the coefficient a? By substituting x by 1. So I'm going to have 9 equal a times 1 plus 2, plus 7, I'm sorry, plus 7, times 1 minus 2 plus I, times 1 minus 2 minus I. That gives me equal 8 times 1 minus 2, it's minus 1 plus I, times 1 minus 2 give me minus 1 minus I. I can see right here that I am dealing with a plus b times a minus b, and I know it's supposed to be equal to a squared minus b squared. In that case, it's going to be equal to negative 1 squared minus I squared. And that gives me a 1 minus negative 1, 1 plus 1, and it's will be equal to 2. So basically I end up to have a 9 equal a times 8 multiplied by 2 because this is equal to 2. So I end up to have 9 equal 16a. So a equal 9 over 16. And therefore, my polynomial, p of x, is going to be 9 over 16 times, and it's going to be x plus 7 times x minus 2 plus I times x minus 2 minus I. And when I distribute each parenthesis properly, slowly, I'm supposed to have at the end a p of x equal 9 over 16 x cubed plus 27 over 16 x squared minus 207 over 16 x plus 315 over 16. All right, thank you very much, guys. And I'm going to add more problems for this section 4.3.